Hi, everybody. Um, yeah, so I promised I'd do a little video on this one too, just because of the similar triangles. But just real quick, you could read, and these are all blocked out. But this is really, again, um, I honor the book that we have because it is very user friendly, and so I cut parts out of it for notes and have you take what you need to take during the year, and hopefully you're okay with that because why am I reinventing the wheel when the book is so good? So I cut these things out, and they're good reminders of what you're supposed to know, about this first concept specific to 1-2. So, hopefully you just read that and remember those things. And what I've always said with this is, let's pretend that transversal is really slanted. Well, that angle looks like it's obtuse, and that one looks like it's obtuse. So more than likely, they're equal. This is only if these two lines are parallel that are cut by that transversal, but of course, you know what that means. So yes, alternate interior angles are congruent. Alternate exterior angles are congruent. I'll mark those as congruent as well, and so on and so forth. Look, you have an obtuse and acute. Those can't be equal. Oh, so they must be supplementary. Same side interior. Same thing with same side exterior. And then, remember that name. What I always said corresponding angles are, excuse me, is angles that face in the same direction on the same side of the transversal. So acute, acute. Okay, they must be equal. But if you remember their corresponding, that'd be great. Because then that leads to these questions. Well, these are vertical angles, so they must be congruent. These are alternate exterior angles. They are congruent. And if you still can't solve an equation, that is not my fault. Okay? So we got to get good with our algebra skills. Some of us are still lacking with that. All right? These are same side interior, so they're supplementary. And that's why you see the math that I have there. And in all these cases, once you get x, to find the angle measures, angle 1, 2, 3, and 4, you plug in 11 for x and evaluate. All right, and then I love these proofs of how a triangle, three angles add up to 180. It's actually related to alternate interior angles. So here's angle 1. If I draw a horizontal through this line, or this segment of the triangle, and then a parallel of one up here, then these two measures here and here are equal because they're alternate interior angles. Same thing with this. These two angles are equal. I'm just putting weird little markers there to show that. Well, of course, anybody knows that these three angles up here added together equal 180. So that implies that these three angles added together equal 180. Very interesting proof. Never saw that until I taught out of this book. It's always something that was just told to me as well. I'm like, okay, 180 degrees, gotcha. So good stuff. All right, and that leads to this. These expressions added together should equal 180. Blah, 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 blah. Then you plug in 15 back to find these specific angle measures. Can't help you on this. These are just flat out definitions. What I call that concept number 4, geometry review. And then here's the big one, okay? Concept number 5, similar triangles. Look at my chicken scratch over this. Of course, angles are congruent. Corresponding angles must have the same, I just noticed a mistake there, same measure or congruent. But corresponding sides are not equal. One triangle is bigger than the other. So they are proportional to each other. And then that's denoted in this over here. I put one representation of this for these triangles over here. And I did small over big. So side AB goes with side DE. Why? Look at the angles that connect them. They're equal. Like, it's the best way I can explain that. But that doesn't mean AB equals DE. AB over DE is equal to, and I think I should have equal signs here, not, for a math stickler. I'm not even going to get into it. At this point, it doesn't matter. So I'm going to put like 2 marks on these. That means those two sides correspond to each other. Now notice it's small over big again. BC over EF. If I flip these and I leave that alone, then that's wrong. Small over big equals small over big equals small over big. Small over big. All right, and I'm just marking those as those are the ones that correspond to each other. So proportional. We could flip all 3 of these, then we're okay, of course. All right, and then this is the kind of stuff when it comes to algebra, you got to be very careful on this. And I wish I could, you know, expand on this picture more, but I will as much as I can. Name the corresponding angles and corresponding sides. Okay, that's not too bad. When these are parallel, then we can use and incorporate concept number 1. First of all, angle G, that's illegal, by the way. You can't call that angle G. Which angle G? This angle, this angle, this angle, this angle? You can imply that this is angle G, a straight angle. I mean, no way. No way. So rarely what you should call this is angle HGK or KGH. And that angle is congruent to this angle. And that's what they're saying, and they set up here. Well, they say name the corresponding angles, but I'm going to name the relationships. Of course, HGK is congruent to FGE or EGF. It's illegal to name that with one letter because G is it's like a 4-time in vertex, even more than that. Oh, it's like a Jerry Springer show. Which vertex are you for, G? Come on, make a decision. Anyway, and then, all right, because of all right, here we go. H, we marked that with 2 marks. Now that is equal to F because these are anyone? Alternate interior angles. So if you're playing at home and you actually answered that, good for you. And if you didn't, you're sitting there drooling as you listen to me like you do in class. All right, and then next, here we go. 1, 2, 3. 1, 2, 3. Okay, and now I can name these with one letter. So I did angle F to H. It doesn't really matter which side. I know I just made a big deal about the proportions. List small to big, big to small first. So top equals bottom. Then I did bottom equals top. Who cares? It's not relevant on this, but I probably should have been consistent with that. But who cares? Angle K. You got to Miss Rest. Who cares? Angle K congruent to angle E because they're alternate interior as well. Now, what this makes, I'll do this with highlighting. Who does H go with then? Or I'm sorry, GH. What side is that proportional to? And you probably figure it out just by looking, but it's this one because this angle, this side is connecting the 1 mark, 2 mark angle. 1 mark, 2 mark. But they're not equal. Now you got to be really careful here. GH, its measure, excuse me, is, and it doesn't matter if you do GH or HG, order doesn't matter on naming a segment, FG, not equal, proportional to some other fractions. And I'm sure no one would miss this. Of course, probably everyone would get that right, that HK goes with EF, but look at the markings of the angles. 2, 3, 2, 3. Yep. So KH over EF. You know what? I was wrong up here. Nobody cares about this, I know. But in case some math teacher is sneaking on and trying to, judge, am I doing the right thing? Does this guy know what the heck he's talking about? I think those should be when you have, I think when you lose the mark, turn this off, by the way, fast forward this, my students, because it doesn't matter, but I think when you have that mark, it is a congruent sign. When you lose the mark, that implies measure of a segment. So, just delete that from your memory. My class, it doesn't really matter, but I just want to make sure no one's watching me out there. I get a little suspicious. Equals, I always feel like somebody's watching me. All right, and then GE. Okay, so that's GK goes with GE, 1 3 mark, 1 3 mark. So that's how you denote that. Now this one's easy, but this is what you do next. For the proportionality of stuff, I mean, look at this. 1 2, 1 2. Of course, A goes with 10, but A doesn't equal 10. A over 10, large over small, should equal, well, it's the only one that's given. Both of them. 4 things and 1 unknown is perfect in math. And then you cross multiply. So this gets into the stage of what do we do to get these answers? Oh man, I don't know. Get your calculator. I don't feel like thinking. And then the next one, I mean, come on. Why do I have to do everything around here? B over 20 equals 75 over 25 as well. Then you get 25B equals, oh boy, 750. This is going to be embarrassing if I have 14. 1500. Then I should be able to divide by 20. I just don't feel like it. I'm going to move on. All right. Oh. Okay. Oh, I didn't mean to leave this. All right. Oh, yeah. Okay. This is what you need me for. All right. So I do have 2 triangles here, and we're going to find the missing value here. So I have that, and I have that triangle. And if it would help you, maybe to, because I'm a little short on space, I'm going to pull the yellow out here, and then pull the green one out, and just I'll make it look like a little bigger, but I just want really, and then you can make it like this. This question, you really could, and make it easy, and go from there. All right. So you look at that yellow triangle, and this one's a hundo, right here, and then this one's 90. All right. What's that little 10 there? Huh. What does that mean this is then? Well, you should figure out that it's 90 plus 10, which is a hundo right there. And then this is C. Once you look at it like this, how do you solve C? It's simple now. Look it. It's just like this question. It's redonkulous. All I got to do is do a hundo divided by C equals, because, Mr. Samuelus, a little too fast. How do I know these 2 triangles are similar? We used to have not used to, they exist. Postulates that prove 2 triangles are similar, not equal. SAS is one of those. Do you remember that from your geometry days? Do we even teach geometry in these convoluted Math 1, Math 2, Math 3 classes anymore? Who knows? All right. I believe we have SSS similarity, but that doesn't mean all 3 sides are equal. All 3 sets of sides show the same proportionality. Therefore, the triangles must be similar. But then there's one that doesn't exist for, and I think there's some more, I don't care. There's one that doesn't exist for equal triangles, but for similar ones, yes, AA. So why is this angle similar to that angle? Or, I'm sorry, equal. Because it's shared. An angle is equal to itself. All right? Now, you can't go further from this. As a Federer you can argue that you could come up, if this is the question on the test, and say, these triangles, by what I have in this drawing, are not similar. And you'd be right. Because what's missing is the assumption that they're making that these 2 things are parallel right there. Without those parallel symbols, you should not be able to do this question. I know I brag about this book, that I love it, but this is a little mistake on their part. True story. Anyway, why are these 2 angles? And I know what you're going to say, and stop it immediately. If you say because they're both right angles, you're wrong. It's not a right angle until you see a square in it. That angle, actually, I measured it. It's 89.99 degrees. Wrong, sir, or ma'am, or whatever. Okay? But why are they equal? It's because they're corresponding angles, with being cut by a transversal of 2 parallel lines. 2 parallel lines cut by a transversal. Corresponding angles are equal. And we're done. By AA similarity, this 3rd angle has to be equal to this 3rd angle, and therefore these triangles are similar. That's a definition, a big part of similar triangles. So the sides must be proportional. Oh, over-explaining Samulus. He just cares about his students so much. It almost makes him cry. 90C equals, oh, you know what? I'm tired again. Divide by, I do it right. I'm just going to double check that. And then you could calculate. I could cancel it. And then something else happens. You get a decimal. Whatever. So 100 over C, right, equals 90 over 100. I went small to big equals small to big, small over. And then I'm just going to have the answer appear that I pulled off, some pictures off the internet to show you this, final answer from the key of the notes. But what you have to understand is the sun is so far away that even you and, is it the Sears Tower anymore? I like calling it the Sears Tower, like I still call White Sox Park Comiskey Park. Anyway, Willis Tower. Nice, Mr. Samulus. The angle that the sun, even though the Willis Tower is way bigger than us, the angle that the sun, because it's so far away, it hits Willis Tower at the same angle as it hits tiny puny little us because it's so far away. Now if I put a flashlight and I put a flashlight like right here next to the building, then it would hit this right here, and then a shade would go like this, and we would even get missed by that flashlight. Again, over explaining Mr. Samulus. But the sun is so, look at this, The sun is like so far away. It's like way over here. It's so far that it would hit us both at the same angle. It's an amazing concept. All right. So anyway, why would I go through all of that? It's because I know a truck is not very large like the Willis Tower, but it's the same idea. So I'm going to pause and pull my video, or not video, my notes that are completed with the beautiful pictures to denote that point one more time. And there you go. I pulled it right off of the our online calendar completed notes thing. So the idea is this. That angle right there, the angle that the sun hits the top of this lighthouse and hits the top of this truck is exactly the same because the sun is so far away. All right, and I know no one would think about that. I just like to really like back to this question. This question's invalid until they actually mark those as parallel. So yeah. Oh, hey, there's the answers. Nice. Okay, good. But anyway, I calculated it back in the day for those students. You guys got cheated. All right. So it's similar triangles by AA. And then we make that assumption again that the lighthouse and the ground is horizontal and the lighthouse is vertical, just like the ground is horizontal and the truck is vertical. So we assume these right angles. All right. With that being said, it's AA that the shade or the shadow, this length and this length, these are proportional sides because these two triangles are similar. So in order to find, we could do this. We could do this. We won't, but we could do this. We could go outside and measure like the height of trees by look on a sunny day and look at our shadow and our height and compare it to the length of the shadow of the tree. And then we could do similar triangles to find the height of the tree or any structure that's outside. Very simple. Sounds like fun, doesn't it? Anyway, so x over 9 equals 180 over 15. Boom, shaka. I don't know if that's the right assignment. Don't look at that. Always look at the calendar. These are ancient numbers. The calendar always takes over that. Alrighty. Have a good weekend. It's good to see you again. I was bored at home doing nothing, sitting on the couch, eating snacks.